This is chemistry lesson 2.11 to 11, and today we're going to write some word equations. So we're upping it a little bit. We're going to take it to the next level. Not the top level yet, but the next level. So today we're going to write the whole equation out, formulas, and then balance. You never guess. We've been teaching this in class all year. Follow the pattern of the class. What did we learn how to do first? What did we learn how to do second? What did we learn how to do third? What did we learn how to do next? That's the pattern you have to follow to do this. And let's quit talking about it and start doing it. And here we go. So, what did we learn first? About the periodic table. How to find charges, and things like that. What did we do next? We learned how to write formulas with those charges. What did we do next? We learned how to balance equations. So that's what we're going to do right now. Let's start it off. Oh, I also highlighted the diatomics for us, and I put them in bold. So when you get a diatomic, remember, it has to be in that format. All right, let's see what we got here. All right, we're going to start with this top one. It says copper plus silver nitrate. We start off by writing the formula of each thing. Ooh, let's try this indigo. All right, so copper is Cu. Now, if you don't know that, use your table or your periodic table coffee mug so you know what these things are. And so there's copper. Now we don't know the charge, it doesn't tell us there, so we're not going to worry about that. Copper's not diatomic. Plus silver nitrate. Now, silver's Ag. I want to sneeze. I feel better. Okay, and we know Ag, and we have to find out what that charge is. So what do? We go to our handy dandy. I'll go to our handy dandy ion chart, and we find silver, and silver is right here, number 47, and it is a +1 charge. Okay, so we're going to write Ag +1. Nitrate. What's nitrate? Well, get your chart. And nitrate, of course, is a polyatomic ion. Go to the polyatomic ion chart, and you try to find nitrate. It is right here. NO3 -1. And put that in parentheses, for goodness sake, so we all know what it is. Right? Those parentheses help us in a number of ways. They make it easier to write, and plus it keeps that, it kind of just tells us that it's a polyatomic ion, and we like that. We like to be told what's going on. We draw an arrow. Now, before I go on, notice I left space here and here. I left space so I can put in a coefficient when I need to. Don't jam this all in so small that you can't do it. Now, a lot of you guys will be typing this up on Cami. Typing will be the way to go on this. Now, remember the subscript button. Once you open that text box, there are superscripts and subscripts up there. I personally would probably put the subscripts in the typing and then probably write with my finger the charges above, just because you can put them exactly where you want them. That's my thoughts. All right, so let's get this thing together. It looks like I'm going to have to leave the screen here so you have room to see. Okay, and it's going to form copper 2 nitrate. So copper 2, that 2 means that it's +2. Remember that? It's on the ion chart if you forget that. And it's with nitrate now. And nitrate is NO3. We just looked it up. It's right on the other side. NO3 is -1, and so we have to crisscross those charges. A 2 back there. You could write a 1 behind that copper, but really, nobody's going to do that. plus, leave some space, silver. You could write the charge above there, but it's not with anything, so it doesn't really matter, right? All right, and we left these important spaces. To start off, if you want to write those lines in there so you have a space, that's fine. Now let's look and see what I got here. So first of all, I have to make sure the formulas are already done. And as I went, I crisscrossed and I did everything as I went. I wrote down the name, I wrote down the symbols, I put up the charges, I crisscrossed when it needed to be crisscrossed, and so all of my charges all my formulas are correct. Okay, now it's time to balance. Remember when we balance, we find the most obnoxious thing that's different, and it's right here. Copper 2 nitrate. All right, let's start with the nitrates. Let's do this in red. And this is good to show the different colors if you want to make it look cooler. So we have 2 nitrates on the right. We need a big 2 in front to fix it on the left. Fix the partner now. Now we have 2 AGs on the left. We need to fix that AG on the right. Now we're kind of at a dead end, which is a good sign because dead ends usually mean we're done. Now we'll go back and check our coppers. We have 1 copper on this side, we have 1 copper on this side, and we are done. Okay, now look at this last thing that's written up here. The coefficients should add up to the number at the end in parentheses. Well, the ones are optional, so they're not counting the ones. I didn't make this paper, I just kind of changed it a little bit, made it more me. And so these ones aren't going to be counted in the add, and so we have 2 plus 2 equals 4. That's what they're doing. Okay, so that's a quick little check for you. All right. Let's see. I will do one fast. I'm going to do this one down here so I can show my face. All right. So iron 3 hydroxide. And let's go with a nice little, I think this is a topaz, I don't know. Fe plus 3. I know that's iron 3 because I look on my ion chart. I really don't because I know what the charges are. You look on your ion chart, you find Fe, it's right boop, here, right? Fe plus 3, you find that. And then you find hydroxide, and to find hydroxide, use your polyatomic ion chart, and hydroxide is OH minus 1. And so you see how that's set up? Isn't that nice? Look how pretty that is. Crisscross 3. I could put a 1 there, but I'm not going to do that. And then we have our arrow. This is called the yield arrow. And so it's showing us what it's changing into. And it changes into Fe plus 3 and oxide. And we all know oxide is oxygen, and oxygen has a minus 2 charge. Okay, crisscross 2, 3. Remember to crisscross. All right, and then our last thing we'll write is water. Now, we can write H2O, or we can write HOH. Now, oops, let's get this screen out of the way here. Or you can write HOH, right? Plus 1, minus 1. Okay, when we look at this problem, the first thing that I notice is that you have something weird going on here. The oxygens and the hydrogens are together here in a polyatomic ion, but the oxygens have been separated up on the other side. You see that? Anytime you have something like that happening, it's going to be a little bit trickier. So that's something to look out for. If you have something, a polyatomic ion that has been split apart, then you're going to have to use the old brain a little bit harder this time. Okay, so let's see what we have here. Start with the most obnoxious thing you see. And when I mean obnoxious, I mean it has the most subscripts. Fe2 O3 is the most obnoxious formula we have on there in Mr. Arnold's definition of obnoxious. So let's start out with those FEs. And let's go back to, let's use a nice orange color. So we have 2 FEs on the right, and we're going to go over to the other side and make it 2 on the left. Okay, now we're dealing with those oxygens and those hydrogens. So let's think. We know that they split apart, so we're going to do them individually. And this is a variation of what we normally do. So let's start with these H's. You have 2 out front and then 3 behind the parentheses. So that means we have 6 H's. Let's fix those H's first because the H is by itself. Leave the O's for last. That's going to be the trick. Leave the O's for last because they've split apart. So here we go. We're going to put a 3 in front of that. That gives me the 6 H's. Now let's add up those O's. We have 3 O's right here. And we have 3 O's already right here. Well, 3 plus 3, that looks like 30, but that's really 3 O's. So 3 plus 3 equals 6, and I have 6, and we're already done. And we can put a 1 there if you choose. I know most of you probably won't after you get good at this, especially on the ones you're right. And we'll add up our subscripts. 2 plus 3 equals 5. Okay, I hope that helps. That was a tricky one. Sometimes you just have to, it just takes practice, I should say. You have to think outside the box sometimes. Hopefully everything works out the easy way, but that just doesn't happen a lot. All right, hey, have a great day. I will be back with some kind of key for this. I'm not sure what I'm going to do with it.